Hello students, welcome to the series of lectures on digital speech processing. So in this video I am going to explain about the classroom discussion topic on pitch period estimation using parallel processing approach. So in the previous videos we have already explained about what is the main important consideration which are required for the time domain processing of the speech. Now from this video we are going to be analyzing what is a pitch period, how we need to estimate using the appropriate approaches. So let's get started with this. So this is the lecture learning outcomes. On completion of this lecture, you'll be able to estimate the pitch period using parallel processing approach. So before I explain about the algorithm or the parallel processing approach procedure, so first we need to understand what is a model of a pitch. Okay, I clearly mentioned some of the most important points which are related to the calculation of the pitch. So the first point in the slide is that the speech signal. Let me take the pen so that you can easily refer to the point what I am mentioning. So when you require the first point, the speech signal, it can be classified into voice, unvoiced, and the silence region that we already know how it could be. Okay, so let me draw that. So this is the speech signal, this is a voice signal, and then this is the silence, and again this is the peaks. Different peaks will be having according to the sentence which are spoken by the speaker. Okay, so it can be classified into voice and then unvoiced and the silence region also. So during unvoiced there are short noise that are also going to be accompanied with the speech. So coming to the second point, the voice regions looks like a near periodic signal in the time domain representation, and in a short term we may treat the voice speech segments to be periodic for all the practical analysis and the process. So that is what we clearly seen in the previous videos. Okay, so when you take the complete speech signal and how we are slicing that speech signal into the parts. Okay, so that I am calling as the segments. So we are calculating the segments of the complete speech signal so that we can easily identify what is the exact words which are spoken by a speaker. Okay, so the periodicity which is associated with such segments is defined as pitch period. Okay, so in the time domain, and pitch frequency or the fundamental frequency that we can term in terms of the frequency domain. Okay, so that is the most important thing that we need to understand. So the periodicity which is associated with such segments is defined as a pitch period. Okay, so why it is required? Okay, for what purpose we are calculating, that also I clearly mentioned. So pitch, it is an important attribute of the voice speech. We can also define, it is measured as a time difference between the two major peaks in the voice speech signal. Okay, so for example, if you take these two, so there could be a possibility for calculating the time. Okay, so this is the T naught I can call. Okay, so it is measured as a time difference between the two major peaks in the voice or speech signal. So therefore, estimation of pitch is one of the important issue in the processing of the speech. That is the reason we are going to be estimating the pitch using any one of the approaches, okay, that we may go for. Okay, but this is the basic idea. You need to understand how a pitch that we can calculate, okay, how that we can observe or the measure. Okay, when you take the pictorial representation of a speech signal in the time domain, this is the way how we are going to be looking for that. Okay, so coming to the parallel processing approach, of course the name itself indicates. So parallelly we are going to be taking the segments and how we are going to be calculating the pitch estimation. Okay, that we can easily identify with the following of block diagram. So in this block diagram, so mainly in order to understand better, so we need to divide into the 4 parts. So the first part is a filter, the second part is the processor of the signal peaks, and the third part is the 6 identical pitch period estimators we have taken, and the fourth one is the final pitch period computation, and at the end of the fourth block we'll be calculating the pitch period of the corresponding speech signal that we have spoken. Okay, So let's begin with the first one. The first what we are doing is that the speech signal we are going to be providing to the filter. So here the filter is nothing but whatever the filter that you can consider. So normally by default we can consider as a low pass filter. Okay, so care should be taken in such a way that we have to design the filter in such a way that it has to reject the hum. Hum is nothing but it can be happens from the 50 Hz signal. Okay, so we need to take care for the designing of the filter in such a way that it has to process the corresponding speech frequencies only, and it has to eliminate the unwanted speech content. Okay, so that is the reason we are going to be taking the first one as a low pass filter. And you can also take high pass filter also you can take, or you can also take the band pass filter, the set of frequencies whatever that you can design. Okay, so it is up to you. So in the advance of the application also we can go for the band pass filter also, there is no problem at all. Now coming to the second important block in this representation is that processor of the signal peaks. Now after at the output of the first block we will be able to see the filtered speech signal. Okay, so that filtered speech signal we are giving to the processor of the signal peaks. So it could be the peaks that can be contains. Now we are going to be assessing each and everything as a some notation like M1, M2, M3, M4, M5 and M6. So in this example we have divided that into the 6 peaks. Okay, so M1 to M6. Okay, so that is a very important consideration here. And after dividing that, we are going to be giving to the third block. So where third block is nothing but so identical parallel processing estimators. Okay, so when you after dividing the filter speech into the segmentations, that is M1 to M6, the first M1 will be given to the parallel processing estimator 1, and the second segment, that is M2, will be given to the PPE2, and similarly it goes on like that. So the last one M6 will be given to the PPE6. Okay, so 6 individual pitch period estimators we are going to be providing, and obviously at the output of that block we will be able to see that so the 6 individual pitch periods separately they are going to be given to the fourth block. So what is the fourth block will do? The fourth block nothing but the final pitch period computation. So it is going to be collecting all the pitch estimations from the PPs, from the respective PPs. For example, if you want to say the pitch period from the first segment, we are going to be collecting from the first PPE, first estimator, and similarly second estimator we are collecting that, third, fourth, fifth and sixth. So total all the estimators we are going to be collecting the pitch periods, and that will be given to the fourth block, and at the output of the fourth block we will be having the complete pitch period that can be possible. Okay, so actually this is an algorithm so which was developed by Gold and Rabinar. Okay, so they both have developed this parallel processing approach. So in such a way that how we are going to be calculating the pitch period estimation. Okay, this is very important approach, and it is very simple to understand also, because parallelly we are going to be estimating, not sequentially. Please understand, parallelly we are going to be estimating each and every segmentation of the speech, and obviously at one time in one cycle we are going to be calculating the total time period, or the fundamental period we can call, or the pitch that can be estimated. Okay, so whatever the points I clearly mentioned to you, the same thing I have represented in the sentence form. The basic principles of this approach are speech signal is processed to create number of impulse trains which retains the periodicity of the original signal. Actually we are going to be focusing on the speech signal as an impulse. Okay, if there is no impulse at all, there is a voice, unvoiced signal or the silent signal. Okay, so voice signal can be represented as the impulse train, that we already know. So this processing allows very simple pitch detectors can be used to estimate the period of the impulse. So the estimates of these pitch detectors are combined to infer the period of the speech waveform. So the parallel processing approach to pitch period estimation is a method that utilizes multiple processors that we have already seen in the block diagram, or codes, to perform the pitch period estimation in parallel rather than sequential. So this can significantly reduce the computation time, obviously, because parallelly we are going to be estimating each and every segmentation, and then we are calculating the pitch. Okay, so obviously we are reducing the computation time. Okay, with no time we are going to be calculating the pitch period. Okay, and the basic idea behind this approach is to divide the input audio signal into overlapping frames and then computing the pitch period estimation for each frame in the panel. That is what. So these are the basic measurements actually in the filtered, how we have given the M1, M2, the peaks, the signal peaks. This is the way how you need to understand. If that is a sinusoidal, and how we can give the signal peaks from the filtered speech. Okay, so these are the basic measurements which are made on the filtered speech. So M1 we have given, normally M1, M2, M3 we have given in the positive peaks, and M4, M5, M6 we have given in the negative peaks. Okay, this is the way we need to understand. And of course, so I keep on telling that the impulses, right? Okay, for each and every peak we'll be having the impulses that we have driven. So total M1 to M6 signals we have analyzed from the, if that is a true sinusoid, this is the way, M1, M2, M4 and M5 you can clearly visible from this graph. So M1, M2, because these are the positive, right? Listen, M1, M2, M4 and M5, that can be clearly visible if that is a pure sinusoidal waveform. Okay, and measurement when input contain the strong second harmonic and some fundamental measurements M3 and M4 are also correct. Okay, and similarly, whereas M1, M2, M4 and M3 which are incorrect according to the second harmonics. Okay, so this is the way how we need to analyzing the time true period, or the what we can call is that pitch period. Okay, so successive two peaks we clearly defined in the first slide of this video. So what we have defined, so the time difference between the two successive peaks is nothing but the period. Okay, so if that is a true period, that can be seen from here. Okay, but when you see here, there is no successive peak. Okay, it is missing, and we are taking the next harmonic. Okay, so that way we are going to be having some of the impulses we have calculated from the peaks. Okay, so this way how we are going to be estimating the pitch period using parallel processing approach. Thank you, students. Thank you for watching this video.